Hello everyone. We have Anton Aripov from JetBrains, and he's going to talk about Kotlin DSL under an hour. So to introduce him, he is the developer advocate at JetBrains, and his main focus is towards server-side and Kotlin cloud application development. And obviously, because he's part of JetBrains and working on server side, we can definitely assume that he's doing all of those in Kotlin. So yeah, Anton, the stage is yours. Feel free to share your knowledge.
Hello and thank you for the introduction. I'm talking to you from Tallinn, Estonia. It's an early morning here. It's still dark outside, uh, and I was late a few minutes because I just slept in, and well, waking up early on Saturday is a little bit too hard sometimes. But yes, we are going to talk about Kotlin DSLs, and let me share my slides. I guess here's the sharing window. Share the screen. Someone should share my slides into the broadcast, and here they are. And yes, our topic today is about Kotlin DSLs. In fact, I think it's unfair to call them DSLs because they are not really languages. It's the idiomatic use of Kotlin API or the language features, and we are not creating any new languages when we talk about DSLs. But let's start step by step today. So when we talk about the main specific stuff, it means that we are talking about things that are tailored for the specific task. And well, when we talk about the languages, it comes to the external DSLs and internal DSLs. When we talk about external DSLs, we actually have tools for that as well. Normally, we would create a grammar, some sort of a grammar description. Then we would have some tool to generate a parser, a lexer, code generator, and so on. So at JetBrains, we actually have a tool called MPS. Was it model workbench, basically, where you can describe your APIs, your grammar, and generate a parser and generate a generator. Basically, MPS is an IntelliJ-based product. It's free, but we are not talking about that today. We are talking about Kotlin, and this is how MPS looks like, actually. And when we talk about internal DSLs, we are actually limited with the basis of the host language, like Kotlin. And so we talk about internal DSLs today, stay on the dark side. And before I go into coding, I would like to show you a few examples of the DSLs that we already have today in Kotlin. So this is the example of Kotlin XHTML library, right? Even if you didn't know anything about Kotlin, you would see, hey, I totally understand what this code does. It generates HTML documents. And the other example we have is Gradle Kotlin DSL scripts. It's a little bit more complicated, but still bearable. You can still read it. There is an exposed library which provides a DSL for working with databases. Like you see, there's a description of a table called cities. There is a transaction starting. We create a table cities. We populate the data. We query the data and print it out. Simple. Another example, for instance, Spring is adding a new DSL with Kotlin, where you can describe and configure your DSL context. Here is just a small excerpt from from their GitHub account, configuring a web application with logging, beans, the port starts, and there are mappings, the URL mappings for handling the HTTP requests. The other example is, for instance, creating configurations for Kubernetes. Well, normally you do that with YAML files, but YAML is not fancy enough. We can do that with DSL as well. Or in TeamCity, the build server that we built at JetBrains, we can use Kotlin to configure build configurations, to configure your builds. And Ktor, of course, Ktor is a web framework where you have a little DSL for routing, pretty similar to what we have seen a few slides ago with Spring, a little bit more concise, and it mixes two blends of DSLs here. In my example, there we have a part that starts with routing configuration that is Ktor specific, and next we see a familiar example from the first slide where we have HTML document generation. We start mixing the languages in the same file. And that's possible because it's not really the different languages. It's still the same language. It's Kotlin, but it's just a idiomatic use of the language, right? So it's still the same language, but we can mix it in the same file. So all those examples were pretty similar. And in what way? They all start with some sort of an entry point. Let's say create user, create web server, create something. And there is a first word. And then it's a function. It's normally a function. And it takes a block as an argument. And inside that block, we may have another function like this, which also takes an argument. And so on. There could be an assignment of a property as well inside the block, and assignment to a variable that is assigned by a function, which produces a result, and so on. So we get this kind of a nested structure, which is supplied with some sort of syntactic sugar provided by Kotlin, and well, it's all objects and function calls, and of course it's syntax colored, and it looks like magic when we actually see it working. But well, let's see how this magic works inside the IDE. We have some examples. We are going to go through this small example tab prepared, and see how all those language features actually result in this kind of a nested structure, which looks very much like a DSL, like a specific DSL, but there is no specific grammar. We would just develop a vocabulary instead, and get the nice result out of that. So I have an ID here, and let me go through Java code first. So I actually have an example of Java code where do I have it? Model. Yes, model. So I have an example here. It's a simple Java code, builds a client. So we have a client. We have first name, last name for that client. This client has a Twitter account with a handle and a company name, and the company may have its own arguments. In this case, it's the name and the city of the company. So just a simple domain model that we are working with here. This Java code is pretty simple to read, right? So it's nothing wrong with this Java code. There is no catch. It's very simple. And excuse me. And yeah, let's check what's inside as well. So those are just Java beans with setters and getters, and we have classes for each domain class. So in this case, we have this builder, client builder for the client. Client is client looks like this. And we are going to make changes in Kotlin code. So for a little, let's say, limitation that we are going to do here is that the Java code, we assume that it comes from a library, so we don't have control over the source code at the moment. We just see it here, but we cannot change it. So we are not going to change any of the Java code, but we are only working with Kotlin files instead. Okay, so here's my example. I actually should just copy my Java code from here because I don't want to be typing everything in by hand. All right, so I copied the first example right into the Kotlin file. Of course, IntelliJ sees that I'm copying a Java code into Kotlin file, so it suggests me that I can convert the source code and performs the first conversion for me. Let me switch out the notifications. Well, the first set of conversions has been done. We can see that the type information is replaced with val keyword. We don't really have any type specification for any of the variables in this code. The new keyword has been dismissed, and semicolons are removed. And even if I type those in, they're optional. IntelliJ will tell me that well, the semicolon is redundant, and please remove that. And the one more change that has been done compared to the initial Java version is that this string here uses the string interpolation instead of string concatenation that we have in Java. If the code works, we can verify that. Let's see. It builds. Oh. When sharing the screen, the compilation is slightly slower because of the resource consumption. But anyways, so we have this create client is, well, and we can see not a string, but some sort of a client object ID instead of a beautiful string. So how would we fix that in Java? Normally, the approach is that we create a function, something like print, and give it a client instance, and return a string. And do something like this: return client Twitter handle and client, let's say, company name, client company name, nothing fancy. So this is the way we do that in Java, right? But we are in Kotlin, and in Kotlin we have more idiomatic ways to work with that. So first of all, we don't really like this function only works with client. In Kotlin, we would rather use extension methods. Of course, we know about the extension methods, and let me call it a little bit differently, to console maybe. And it wouldn't take any arguments. And then we don't have to specify the body, or like the name of the variable, because this method works already with the client's data, like this. It's a company name. And then since it's a single function, we can actually transform it into the expression body. And we don't really need to specify the type parameter, return type of the function. We can just remove it, and this code looks more concise. And even we can improve it a little bit more by converting the concatenation into the string interpolation instead, like this. And we can start using this function, like to console boom, and the result will be much prettier when we see it's printed out. All right, so created client is Anton from JetBrains. Okay, so that's the first step towards our transformation with the code. We know about extension functions. It's a simple building block for our DSLs. In fact, let me see what we can do, what else we can do here. So when we're talking about DSLs, it's often the benefit of using DSLs is that they are much conciser. And when we fight for the conciseness of the DSL, we want to find for every character here. So even with this code that we see here, we can do a little improvement actually by removing those braces. How can we do that? It's to console. It's not a method anymore. We can have extension methods, but we can also have extension properties. In this case, we would, replace this with a definition of a property instead, and have a getter. Boom. We already have even less characters in our client code. We don't have to specify those braces. It still works. It's still the same result. Must be the same result. Yes. So we can win even like small characters by using the different constructs. For us now, it's not really important right now. I just wanted to show you that we have extensions. We have extensions for as functions. We have extensions as properties, and we are going to have extensions as functional types as well. And we are going to see that how it helps us with the DSL creations. So let's get back to our code here. Remember, I was saying that there is a nested structure normally with the DSLs. Like when you create DSLs in Kotlin, those idiomatic constructs help you to create a nested structure for your DSL. And we are going to move towards that. So the entry point was usually a function. And it was usually something like create a client or create something else. And in our case, we are building a client. So we are going to have a function that creates clients. So fun, create client, well, normally it should take a block of code, right? So it should be a block of code. And a block of code in Java is a functional interface, right? But in Kotlin we do have lambdas, so we can use lambdas instead, units. And the lambda can return a block of code, but it can also be like something that returns a value. But in our case, we just create. No, I should actually start this example with a Java interface. Let's see how it transforms and to better understand why you are ending up with a lambda instead of something else. Right, so we do have a consumer interface in Java, and we are building client builder. It's going to be a client builder, and it actually creates creates a client. Right? So to do something with the client builder, we need an instance of that. So val builder, client builder. We have an instance of a client builder, and we need to pass this client builder. A typo. We need to pass this instance into a block of code. We have a lambda which has one single interface. This consumer interface has an accept method. We pass in a builder function and a builder object. And once the block performs any work with the builder, at the end, after this operation, we will have a result inside that builder and we are going to just call build and return it. So that will be the result. It returns a client. So let's see how this function will be used actually. So we have a client object, client variable already here. We are not going to use it anymore. Actually, we will use it, but we are going to assign it a little bit differently. We are not going to use the builder directly. Instead, we are going to use that function that creates client and pass in a block of code. So in block of code in Kotlin, we have to create an anonymous object. Since it's a functional Java interface, client builder, and this way we have a block of code passing into that function. And we need to implement an interface. Create client. Oh, it's not a client builder. It should be a consumer. Consumer, of course. My bad. And implement the members. So we have an accept method. And the context and the body of accept method should be populated with the code that actually builds the client, right? So we have it already here. We just move it into this method, and we already can see a little bit of transformation with our code that happens, right? We do have some nesting already. It's the first level nesting, actually 2 levels, but not really. But we have some clutter. We have some Java clutter here. We can do a little bit of improvements. And first of all, IntelliJ tells me that it's a Lambda. It's actually a Lambda. You can move it out from the, or you can convert to Lambda. Boom. A single struct, and we suddenly have a clean nesting, right? So we have a function call, an entry point, and we have a block of code. It looks very nice. We can get rid of the functional interface actually by moving to native Kotlin lambdas. So the block of code is actually a lambda that takes in a client builder as an argument and produces no result, right? In this case, so we have a we don't need a consumer. We say that the client builder is an argument of a lambda, and it returns a unit. And since we don't have the accept method name anymore, we have a functional type. Instead, we can just remove this accept here and call the block directly by passing in a builder parameter. Nice. So we got rid of the Java interface. We have a function call with the block of code, clean and nice, but there are a few things that we can improve. So the builder argument, right? So it takes a builder as an argument. It's a single argument here. And if we, since it's a single argument in Kotlin, it can be called it. And it's an explicit name, implicit name, implicit. So if we specified it right here, well, we don't need to type it like this. If we specify it right here, IntelliJ tells us that, hey, you have a single argument lambda in your code, and you don't actually have to type it as an argument here. You don't have to define it. You can just remove it. And we have it as an implicit parameter, and everything that you can refer at in this block is it, and it's a client. It has a type of client builder. So, but it would be much nicer if I wouldn't have to type it for every assignment, like first name, last name here, right? I would like to just type first name and be able to assign a value there. How can I do that? In fact, it's really possible by saying that this block of code doesn't take a client builder as an argument, but instead it should be an extension to that type. So we can just say that this lambda is an extension to this type, and everything that happens inside that block is actually happening within the context of the client builder. Oh, that's cool. So the first name now belongs to client builder, and instead of it, we have this as implicit variable inside this lambda. Nice. So we actually can just now remove those calls to it, and we see that the first name, last name is is assigned, and everything compiles, and they belong to the client builder. And we can go further on with this transformation and use the same trick for the rest of the code that we have. Right? So, for instance, for Twitter, I would like to have something like Twitter. Open a block of code, say handle, and assign a handle, right? So I would like to have something like this instead of this. So for this, I have to specify a new function, right? So the Twitter function should take a block of code, and it should be an extension to the client builder, but it should work with the Twitter builder instead. Okay, how can we do that? So function is an extension of a client builder. Client builder Twitter. And the block of code should be executed within the context of the Twitter builder. Block and Twitter builder. And we say that it's a lambda. It has no parameters, and it takes a unit as an argument. We don't really have to return anything. We don't do any assignments from that function. We just have to assign, we just have to perform the operation, right? So how do we perform the operation? We have to assign the result of the operation to the Twitter field of the client builder class. So we have a Twitter and assign the value, and now we have to execute the block of code. But the block of code should be executed within a context of the Twitter builder. So we can just create an instance of the Twitter builder, and then there is an extension function for every type in Kotlin called apply. So we can execute this block of code that should be executed within the context of the Twitter builder, and there will be the result, and everything that is left is to call a build method to actually get an instance of the Twitter object, of the Twitter class, and we can make the assignment, right? So that's simple. Same for the company. So we could have like a block of code called company. It will be an extension method again. Then we don't need the company builder right here. We would need to do the assignments within that block, right? And I would like to get rid of this company builder variable as well, so I can just remove that and assign the fields directly. So this is what I want to do. And basically it will be a very similar method, but instead of a Twitter, it will be called company. And it will happen within, the block of code should be executed within the context of the company builder. And it should assign to a company field, and it should be executed again within the company builder context, right? And suddenly our code is all green and compiled. So it's we assign the fields directly within that block, because we have an implicit variable of this, and it's of a type of client builder. The methods are the extension methods to that type, and whatever more nested blocks we have, they have their own context, right? Let's validate. Actually, did we break anything? So the code compiles and it works, right? Let's see now. Let's see what we did. Compared to the initial code, we can actually do a split and see split right. So we had the initial code that looked like this on the right, and we have the result on the left. So what's the difference here? We didn't really, the code is not much shorter, actually. It's a little bit shorter, just a couple of lines, but we definitely have less code to read because we have less characters in this resulting code, right? Also, the code on the right, you have to read it to understand what it actually does. On the left, we have a structure, like with this nesting, right? We have one block of code and we have two more blocks of code inside that. So it's much easier for the eyes to actually look at that code and say, hey, I understand this, right? We can read it much easily. But we actually introduced the complexity. So there is a complexity, which is basically the same number of lines that we had in the previous block of code, but it's even more complex, right? And there wasn't anything wrong with the initial code. Why did we do this transformation? Like, why did we introduce this complexity? Did we really need that? So just doing it for the sake of using fancy language features, it doesn't make sense. Instead, if we start reusing this code, like let's say we move it into a library. So if I have a library like this, and it would provide me the extension methods for my types, then I can package this library, put it into the class path as a dependency, and my code looks much cleaner, right? We don't have any of the extra code here. We just start using those functions. So the bottom line here is that if you start using this code, then there is a benefit. If you are using it just one time, then it's maybe it's not worth it, right? Okay, like this. So what else can we do here? There are different language constructs that can help you with creating the DSLs. So for instance, this entry point is a create client, and we can actually sometimes improve it a little bit. So instead of, for instance, having a name like create client, we could have something like create without any additional word in this method, and instead use generics, for instance, like we could have a parameterized method with generics, creates something, and then the block of code, and this block of code would be executed within the context of that object, and for instance, we can return that type as well. Something like this. And to do, not going to implement it right now. And then this function can be called like this, for instance, client. We are creating the clients, right? Call client. Okay, because I already have this variable, that's why it doesn't compile. And it would create the clients for us. So that's another approach how to do that. We are not going to create it right now. So that's just a simple language feature that I wanted to show. Or the other feature is, for instance, using the infix function. So I do have an example for this one. I created a date of birth attribute for the client class. So there is a DOB and field, and we can assign it a local date, for instance, right? And how do we do that in Java normally? We can create local date of, and then it's a year and a month, and should the month be a number, and what the number should be 11 for December or 12. I don't remember. Maybe there are constants. Okay, there are constants, month, December, and the day, let's say 17. Okay, that doesn't look really idiomatic in Kotlin. So we can do better. Instead, I would like to be able to say that the date of birth is actually 17th of December 2001. Why not? And it is actually a valid Kotlin code. So what I did here is actually I called a December function on a number 17, and this function has an argument of 2001. This is what I did. But let's see what the function is. So there is a December function that I've created for myself, which is an extension to an integer type. And it's an infix function, and it just uses the local date to create the same, right? It's nothing fancy. The LD is actually a local date. We are using type aliases here. Well, it's an experiment. It's not something that you should do because we are adding the December function to the global type. But you can actually if you are using it within a limited scope, then it's probably fine. Right? So it's convenient to use, let's say, this function for this kind of stuff. And since it's an infix function, it takes a single argument. We can amend the typing dot in here, and we can skip the parentheses, and here how it looks like 17th of December 2001, fluent and nice. So that's another feature that we can use for building the DSLs. Okay, so we had a very short example. I hope it helps you to understand how you create DSLs with Kotlin. And if you don't remember anything of my presentation, please remember one thing. Extension, we have extension functions, we have extension properties, but we have also blocks as extensions, right? So the official name is lambda with the receiver, and the receiver is a type on the left, and then we type a dot, and then we type a functional type signature. So we can use those lambdas with the receiver, or functional blocks of code, to build nesting for our DSLs, and it's pretty helpful. And it's just a language feature. We don't create a grammar. All you have to think about is to how you call your function names, right? That will be your vocabulary for the DSL. If you want to learn more about Kotlin, there are plenty of books. There are courses at the Coursera's website, and there is a Kotlin Slack where you can ask questions from our team and from the community as well. I'm Anton Arkhipov. You can find me on Twitter, and the slides deck that I have here is published at speakerdead.com. And I hope it was interesting. I hope the example that I have created for you and demonstrated was interesting for understanding how you can use Kotlin to build your DSLs. And have a nice day. And if you have any questions, I can take them quickly.
Yeah, hi Anton, and thanks for this awesome session. So we have a question with us.
Yep.
In building date DSL, it would be great if we can have compile time validations like the int for data should be less than 32 and greater than 0. Is it possible to enforce them in DSLs?
I hope it will be possible to do this thing one day. It's not possible right now. There is a language feature called contracts in Kotlin, where you can specify this kind of rules in the code, but it's not yet that powerful to implement this kind of functionality. I hope it will be extended, and then we will be able to actually to do this kind of compile checks.
Great. So another question by the same person, Sriharsha Chilakapati. He asked, the generic create might need reified generics, ain't it? Is it possible to associate a builder type with a type at a compile time?
Yes, so you would use reified generics, and indeed, the function that I have created, like the signature, wasn't correct for this kind of task. I was just, quickly showing it off. Instead, we would have an inline function called create and have reified types, reified parameter types, and then you would use Kotlin Reflect library to actually instantiate, make the instances of those types.
Great. Another question by again Sriharsha. It is, please explain about the DSL annotations like we have seen in the comments, in the code, I guess he is talking about, at
Yes.
that client DSL or at that date DSL.
Right. So the date DSL, I can just so this date DSL is my own annotation, which I have created by by declaring it like this. So annotation plus date DSL. In fact, there is a DSL marker annotation in Kotlin, but you don't use it directly. You create your own annotation and mark it with DSL marker. And then you use your own annotation for marking the methods and classes of that specific DSL. So what it gives you, first of all, this DSL marker annotation can solve the conflicts within nesting. So if in our example we wanted, for some reason, we intermix the blocks. So for instance, inside the Twitter block, we suddenly call company. So if I had this annotation implemented for my DSL, the compiler would be able to check that, hey, the company should be actually the top level annotation. It's an extension method to a client builder. It should not be called within the Twitter builder class. So those client builder and the Twitter builder class would be annotated with that specific annotation, and compiler will see the conflict, and it will be a compile time error. We don't have it implemented here, but in our DSL, it's not invalid situation. We can actually do that and get the correct result. But in some other DSL, it's not possible. So why did I add this annotation in my date DSL? Is that in fact it works not only for checking the conflicts, it also helps tooling a little bit. So this December function, you can see it has a little bit different color. Why is that? It's because the DSL marker on top of the date DSL class name, it kind of signals to the ID that, hey, this date DSL may have a different color, and on the left we can see it creates a style. Right, we have 4 styles by default in the ID, and it has a color. Right, and the color, it picked the color by the name. By looking at the name, I think it calculates some sort of checksum or something like this, and picks the color for the functions that are annotated with the date DSL right here. So if we go back to our code, we can see it has that color that we have in the settings. And also, when we create this, when we call this function, let's say we have 17, we type a dot. Yes, it will sort the methods in your auto-completion box a little bit differently. So we can see the extension methods are on the top, and the other methods are following, and the extension methods in that auto completion box, they also have a little bit different color, right? So December 2001. Okay. So I hope it explains why I have this DSL annotation on my function. So in here I have it purely for demo purposes, showing that it may have a different color and different sorting in this auto completion box. Any more questions?
That's a great usage of the annotations in the DSL, Anton. So we have one more question popped in. It says, like, if we are having a team and might be it's very difficult to understand the DSL code by other employees, is it advantage, disadvantage? Like, what is your take on it?
Well, my take is that you shouldn't use the DSL approach heavily. First of all, it has an impact on the compilation performance, of course, because it uses all kind of interesting language constructs. So I think, as I said already, you can create DSLs if they help you to reduce the amount of code that you're typing and makes it reusable. So if you can reuse it in a different projects, then you can create the DSL. So for instance, those examples that I have shown you in the slides, like Kotlin XHTML or Kate or Spring configuration, right? So usually we take a library, it's a dependency, right? And the library already brings in some sort of a DSL flavor, right? So we are reusing the code. And if we are creating a DSL inside the project only for that project, maybe it's not a good idea, right? It might be okay. I have seen projects where the DSLs are created only for that project without any code reuse, but that's a very complex logic. Let's say they generated a DSL out of the database data, like from the table definitions, to work with those tables, and it looked like their own DSL, but it still was created as a library, not inside the same project. So my take on this is you shouldn't create your own DSLs within the project. You should create a library with the DSL and reuse it.
That's an interesting take, Anton. Yeah, I think we are not having any further question. So before we wind up, we would like to thank you a lot because you made your time at so early morning and made this meetup possible. So hopefully we will be seeing you again, or we will get some new chance to host you again in our future meetups. So thanks a lot for joining us, Anton. And
Thank you
meanwhile,
very much for
whoever
having me.
has thank you. And whoever has attended our session with Anton, thank you all. So we are winding up the stuff and see you in the next meetup.
Bye bye.
Bye bye.